Okay, year 7 in half term 4, we're going to be looking at weather and climate. So what are weather and climate? Well, put simply, weather is short term and climate is long term. But we can say that the weather is a description of what the conditions are like in a particular place, or what's happening in the atmosphere right now. So when you look out the window, it might be hot or cold, could be wet or dry, could be windy or calm, or it might be stormy with thunder or lightning. That's the weather. But the climate is a description of the average weather conditions in a certain place for the last 30 years. We can think of that. What's the weather usually like in this place? And different factors affect the climate of an environment. How far away it is from the equator, how near or far it is from the sea, how high or low from the ground it is, or its altitude and its position on a continent. And we can measure the weather in lots of different ways. So we can measure temperature, precipitation, wind direction, wind speed, and cloud cover. Here's how we do it. So with temperature, we use a thermometer and the units are degrees Celsius. For precipitation, we use a rain gauge, which is essentially a bucket with a ruler on it to measure how many millimeters of rainfall we get in a place. Wind direction, we use a wind vane. You sometimes see these on top of people's houses. They show what direction the wind is blowing from. We can measure wind speed using an anemometer, which are like little cups that spin and measure the wind speed in kilometers per hour or sometimes knots. And then finally, cloud cover. We can use satellites to measure cloud cover in octaves. 1 octa would mean that there's not much cloud cover, it's pretty much a clear day. 8 octaves would mean that we've pretty much got full cloud cover. So we can also use synoptic charts to predict the weather. So on a synoptic chart, you have these white lines, which are called isobars, and isobars join areas of equal pressure. Now we can have high pressure, which is going to bring clear sunny conditions and dry conditions, or we can have low pressure, which is going to bring our windy, wet weather. So we can see currently, approaching the UK in the Atlantic Ocean, we've got a warm front, there's these red semicircles, we've got a cold front, which are these blue triangles, and we've got a front where these warm air and cold air mix together. We call that an occluded front. And when we get an occluded front, we generally get low pressure, which means wind and rain, which is why the UK gets such wet weather, because we have a lot of fronts mixing in the Atlantic Ocean. We can use these charts to predict the weather. This is done by the Met Office, who are an agency responsible for predicting the weather in the UK to keep people safe. So we can predict the temperature, we can predict the wind speed and direction. We can also predict how much rainfall, so we can see that on this Saturday that there's going to be some fairly heavy rain. An example of an extreme weather event in the UK is the Beast from the East in 2018. 50 centimetres of snow was dumped over pretty much all of the UK and led to lots of social, economic and environmental effects. Environmental effects, everybody had their heating on, led to massive increase in gas usage, led to a lot of CO2 being produced and released into the atmosphere. Economic impacts, that businesses were losing millions of pounds a day. This was because food deliveries and also essential supplies couldn't get to supermarkets, and there wasn't food or essential supplies on the shelves. And finally, in terms of the social impacts, you can see here on the M80 that loads of traffic had built up and people were stranded for up to 14 hours, meaning they were either late for work or completely missed their shift. So why is the weather so changeable in the UK? Well, one of the reasons is because we get affected by so many different air masses. Maritime air masses are air masses that come over the sea. It's just a body of air that brings certain conditions, whereas continental air masses travel over the land, so they bring drier conditions. The main air masses that affect the UK, polar continental air mass, this is the one that brought the Beast from the East. That brings dry summers, but can bring snow in the winter. Polar means it's cold, continental means it mainly travels over land on its journey here. But we can also have tropical continental air, which comes from places like Africa and Spain and Portugal. Because it's tropical, it's going to bring hot or milder weather. Continental, it will generally be dry, so when we have a hot, dry day, it's usually tropical continental air mass that's brought that weather. Tropical maritime, so tropical means it's going to be quite warm. Maritime means that it's going to be wet, it's travelled all the way over the Atlantic Ocean. This is the air mass that affects the UK most of the time. So tropical maritime will generally be warm or very warm weather, but it's going to be wet because it's travelled over the Atlantic Ocean and picked up lots of rainfall. Final one is the polar maritime air mass. So clues in the name: polar, cold, maritime, travels over the sea. So that's going to bring wet, cold air, and therefore going to bring showery weather, so showers of rainfall. The prevailing wind also influences our climate, and our prevailing wind in the UK is southwesterly. That means it comes from the southwest. If you think about what's there in the southwest of the UK, we've got the Atlantic Ocean, where we saw on our synoptic chart that low pressure building up. That's why we get so much rain, and we're the windiest nation in Europe. That means that the western half of the UK, or the western coast of the UK, is generally wetter, and the eastern side is generally drier. But our prevailing wind, the most common wind, is from the southwest. We're also affected by ocean currents, which is massive movements of water. It's almost like a conveyor belt system that goes around the planet. A warm ocean current, the North Atlantic Drift, also known as the Gulf Stream, comes all the way from the Caribbean in North America and brings warm air, picks up lots of rainfall as it travels over the Atlantic Ocean and warms the western half of the UK. But there's also a cold ocean current northeast of the UK called the Norwegian current. And that makes the eastern side of the UK slightly cooler than the western side. So on a similar day, you'd expect Liverpool and Newcastle, we'd expect Liverpool to be slightly warmer than Newcastle. Next, the water cycle. The water cycle is the movement of water from land to air and then to the sea. So between land, air and sea. Some keywords that we need to know. Evaporation, you know this from your science lesson, water turning from liquid to a gas. When we have evaporation, the air is going to be rising. That can also happen through transpiration, which is essentially trees sweating or giving out water vapor. Once that gets into the atmosphere and cools down, that leads to condensation, which is going to give us clouds, and air will start to sink as it gets cooler. Eventually that will turn into precipitation, which is just a more articulate word for rainfall. How does it get back from rain into the sea? Well, groundwater flow, that does what it says on the tin, it's water flowing through the ground. That can flow through bedrock that is permeable all the way underground back to the sea, or we can have surface runoff where water runs along the surface, but that's quite a bad problem because it causes flooding. Most common clouds that we get in the UK are nimbostratus clouds. Nimbo means rain, stratus means layers, so they're like layered clouds that bring rain. That's most common, but we sometimes get cumulonimbus clouds, particularly in big storms. They're like a big anvil shape. An anvil is what a blacksmith works on. So if you ever see one of those clouds, bring your rain jacket because it means there's a storm coming. Relief rainfall. We talked about evaporation and condensation. Sometimes warm air coming off the sea is forced to rise by the relief of the land if there's hills or mountains, and that can mean that when it's forced to rise, it dumps a lot of rain because the condensation makes cloud. It dumps a lot of rain at the top of that mountain. That can be a problem if we've got human settlements at the bottom of a mountain. On microclimate, this is where a small area has a very distinct or slightly distinct climate from the surrounding area. There's lots of things that affect whether a place has a microclimate. So in a city, it could be heat from a road surface or concrete, heat from vehicles, but also heat building up from building surfaces because they absorb a lot of heat because they are darker. But we can also have things that cool a microclimate. So the temperature can go down because heat is released during evaporation, but we can also have evaporation at the sea. That's going to cool us down because the heat will be moving into the upper atmosphere. This can lead to the urban heat island effect, so all those buildings, all those cars, all that concrete giving off heat means that the city of London, as you can see from this choropleth map, is much warmer than the surrounding rural area because of all the concrete, the buildings and the vehicles. We also see a similar effect in Chicago in North America. The UK experiences lots of different weather hazards, but the main ones are rain, storms, and we can sometimes have thunderstorms, flooding, which is a result of heavy precipitation or heavy rain, snow and ice, or heat waves. One that we're going to focus on is extreme rainfall or storms. So we said the west of the UK is the wettest. The extreme northwest, so northwest Scotland and some parts of northwest England like Cumbria. Those are the areas that experience flooding most often. This is Shropshire, a more local example, so just on the border with Wales, and this is the extent of flooding, and flooding has social, economic and environmental consequences. So socially we can see that people have had their homes flooded, particularly on this side of the photo. That means that they are essentially homeless. Economic, the insurance premiums for the people that live near this floodplain are going to be through the roof because they're at very high risk of flooding. So to insurers, they're at a very high risk in order to insure. And environmentally, you can see that all of this farmland is now completely useless. That ground is saturated, and until that water drains away through infiltration, then the land can't be used for agriculture. This is an OS map of Glenridding, and we can assess the risk of human and physical factors that lead to flooding from this map. So for example, here is the town of Glenridding. You can tell it's popular with tourists because of the presence of lots of hotels, campsites, but also lots of tourist attractions like boating, cycling opportunities for leisure and recreation. But there are lots of reasons why Glenridding might have a flood. One is that you can see the amount of housing here means that there's probably a lot of urbanisation and a lot of concrete. So that's going to reduce infiltration of water into the ground, and it's going to run on the surface and flood. We've also got a lot of slate in the area, which is an impermeable rock. So the water isn't going to infiltrate or soak into the ground. This is also, as the contours are really steep on either side, a very steep V-shaped valley. That means that any water that falls onto this drainage basin is going to fall very quickly down into the river, then it's going to get carried by the river very quickly to the town of Glenridding. Finally, you've got more than one river. So you've got the main river, Glenridding Beck, but you've got lots of tributaries, and where those rivers meet, the confluences are pretty much in the middle of Glenridding town, so we're going to have flooding there. So what did they do in Glenridding in order to sort this? Well, they did hard and soft engineering of the river. Hard engineering, so this is more of the artificial engineering. Well, they dredged, which just means digging up or scraping out part of the river in order to make it wider and deeper so it can carry more water. They also planted trees, so you can see the hills, the steep relief of the hills are quite bare, but around the river they've started to plant trees that intercept the rainfall that's falling and slow it down so that the river has more time to carry the water away before it gets into the river. We can use climate graphs to represent the climate of an area. The bars on a climate graph are always rainfall. I think of them as little cups filling up with water for each month. And then the temperature is the line graph. So this is for a desert, so we can see it's incredibly dry. Maximum rainfall in a month is 20 millimeters, so 2 centimeters. But it's also very hot, we can tell from the line graph, with a maximum temperature of about 33 degrees Celsius. Finally, we can use atlas maps, which are a form of choroglyph map, to show various elements of weather and climate. This one shows rainfall, and we can see clearly the western half of the UK much more rainy than the east, but we can also use it to compare weather and climate. So these are the January temperatures for the UK, and these are the July temperatures for the UK. So we can see that generally the temperatures are much higher in July. For example, I can see that in the southeast of London in January it's usually about 2 degrees Celsius, whereas in July we're pushing 14 to 16 degrees Celsius. So your homework, you can either create your own weather forecast for the next 7 days covering rainfall, temperature, cloud cover, wind speed and wind direction. You can research the causes and effects and responses of a recent flood event, so recent being the last 10 years, or you can research the causes, effects and responses of a named city that experiences the urban heat island effect. So London's a good example, Chicago's another example. Why not have a go at Birmingham?